we'll see here how geometry is created for the water wheel. This is a water wheel is there here, and this is a deflector plate is there. This is a water wheel, this is a rotor, and this is a deflector. We want to create the geometry. We created geometry using the ANSYS space claim. Here is this is the workbench file. Here I have created geometry using the ANSYS space claim. In this simulation, I will model only fluid domain. Solid domain will not be modeled because CFD model solve only fluid domain. Our interest is to understand the flow dynamics. This is the model for the water flow or the water wheel. This is water wheel is there, and the angle between the angle of inclination with respect to bottom plane is equal to 35 degrees Celsius. That's okay. And here water wheel rotor is also there, but that I am hiding. And this is a rotor. But here I am created the fluid domain. Here I am creating a fluid domain. This is the inlet. This is the inlet. This is the outlet, and this is a rotor. Rotor is deactivated. We are not solving for the rotor solid. We are not solving for the deflector. It is a solid. This is a fluid domain, and it is a three-dimensional domain, and you have taken sufficient length to model the flow over the rotor blades. Once geometry is created, the next step is to create the mesh. Mesh has been created using the ANSYS meshing platform. Geometry, all element will be a combination of the hex and tet. See, this is the domain is there. Top surface will be as the symmetry. This is inlet. This is outlet. Bottom surface is the wall. Here see how geometry is created. This is the top surface, and this is the mesh. This mesh has been created ANSYS meshing platform student version. Your mesh you have to physics preference you have to give CFD. Element size give 250 mm. Maximum sizing you can select 250 mm. As a default size 1.5 mm. Quality is 0.9. Statics is a mesh size is a 5 lakh. You have to give the sizing, the cell sizing to the solid, cell sizing to the body. Inflation layer we can give, but have not given that. Inflation layer given ANSYS FLUENT. And this is bond degradation gives inlet. This is the fluid rotor. This is a fluid outer. This is the inlet. This is a outlet. And this is the wall bottom. And the symmetry boundary condition is given at the top surface is given as a symmetry. Pressure top is given. It is converted into the symmetry in FLUENT. And this is the interface is created for the non-conformal mesh because some faces are there. This is faces are there face because it creates a multiple surface. Hence we have given the interface boundary condition fluid. Once mesh is created, everything mesh is okay. Then we have to convert mesh to the FLUENT format. FLUENT export, FLUENT mesh, FLUENT then export. This way we can save as file as a for this model for the rotor model. Once this mesh is created, then we can solve in FLUENT. Just open in Fluent. Just open the geometry. Geometry we can create here. It is a three-dimensional domain. You have to select 3D. Number process 1. First step is you have to read the mesh file. Mesh file is created here. Mesh file you can create here. Angle 25, 35. Just we take a geometry here. And you can see the some boundary condition are there here. You can say display mesh. This is a mesh is there. This is a mesh is there. This is a mesh, and here is a you can convert here to poly. You can convert to poly. The mesh size will be reduced. This poly will be converted, your mesh size will be reduced. See here the mesh size was a 5 element. See here the mesh size was a 5 lakh. But after reading, size will be reduced. You see here, you can see here. Here you will see the information size will be reduced to the 1.4 lakh. Initially size was around how much element there were. Some element you can see is will be 4 lakh. 4 lakh 80,000 tetrahedral cell was there. The size was this one only. Then I read the case data file, which is already I did. This I open this case data file. Once poly is converted, and here you can see the this domain. This is the inlet, this is the outlet, and this is water. Here I just give the one. This is the domain. This is the rotor is there. This is the domain is this wall. This is the symmetry. This is the top. This is domain is there. And here setting in shallow setting, you have to give gravity in y direction, because fluid always move in the flow in x direction, but gravity is acting in the y direction. Y direction I have given gravity 9.8 because y is the downward pressure based solver, transient solver. Here you have to go in model. You have to select HT K omega turbos model. Shear stress transfer model, production limited, this okay. Then next you have to go in the boundary condition. Here inlet I am defining velocity inlet. It's a 0.7 meter per second, and turbine intensity 3, viscosity ratio 5. That's it. And material I am giving the water. Here water have selected density 100, viscosity 0.01. Here from if it is not available, here you can use some water. So fluid you can select as water. Fluid is there. We can select the water. H2 is there. Methane liquid is there. Here you can see helium. No, we are interested in the liquid. Hi, helium, hydrogen, H2O, ice, then mercury. Here is the liquid. We can select the liquid water, liquid solid, liquid. And butane water is there. We can select possibly here. Here water liquid. We have to select here. Click here. Once is selected, then you have to say copy. After this, water will be selected. Water is selected here. This says on. This is a fluid outer domain. They are fluid domain. Fluid outer means outer domain. Fluid rotor is inside. The two domain I created. One is the fluid rotor is there. This is the fluid rotor is there. Fluid rotor. This is a fluid rotor is there. Here I selected fluid rotor. This is a fluid rotor. This is a fluid rotor is there. It has given the rotation. Fluid rotor here defined water liquid as a fluid motion in fluent. Is given RPN is 1.25 as a mesh motion is defined. And for the fluid outer, here is given water, but we don't need to give motion. It is defined for rotor, outer rotor. Then it's over. Then you have to go in the boundary condition once you define velocity, and this is our interfaces. Those are common faces here. Interfaces are defined because of non-conforming mesh. It may not be required. It is just neutral boundary condition for the here outlet is defined. Outlet is defined as a pressure outlet. Here pressure outlet is defined. You have to display here. This is the inlet. This is the inlet, and this is the outlet. Here pressure outlet defined as a pressure outlet. Zero pressure gradient. Fixed pressure. Everything is set. We are solving the density. We are solving turbine kinetic energy dissipation equation. And for the selection factor keeping as the same. We are keeping the moment of second order turbine kinetic energy dissipation as a first order. Control is over. Then go to the monitor. Here you have to define residual as a 10 to the power minus 6 for all variable. Then calculation activity. We can select the animation. Here animation I am defining as a contour 1. So view I am defining the this is the view. This is the velocity contour we are defining. 1. Just OK. Then it will be saved. It save the contour for each time step. Each time that means this contour is saved in JPG file at each time step. Whatever I have given this path is given. It will be saved here. Cancel. And then graphics is there, and here we can see the contour. And this is thing. And then next is the this report. Report is Tarku. This means how is the Tarku? This here report file is there. Report definition is there. In here you have to go in right click. So here the right click. New force. You have to define force momentum. Here you have given the water fluid rotor, and the water fluid rotor is given. That means the surface of the rotor and direction is along the z-axis, then I can define the moment. Here way I can define the moment. Once this moment is defined, then I have given as a rotor torque. The next step is then it will be written as a separate file. The rotor torque, it is given the water fluid rotor, then moment will be saved at each time step. Then everything is set. Then you have to just run it. That means it will be saved same file. So it will be rotated. Sorry, after the simulation, we see the rotation. Just go to file. Different images have taken. You see at different time step, rotor is rotating. Yeah. And we can find out the variation of the we can find out the variation of moment with respect to time, and after getting plot, we can find out the average moment. That way, you can find the torque which is given in Excel file. Once simulation is over, we can find out the contour plot, vector plot. This is also is there. How to find out the path line from the inlet? We can give the some plot. This path line we can also find out. See how path line is there. We can also show the some mesh. Here we can show you the fluid rotor is there. Fluid water fluid rotor. And here view potential lighting. So here we can see a streamline. It is not showing here. We can see here. This way we can show the plot line. You can show this velocity magnitude. You can show here. Is not showing something issue there. Once the plot line is shown, then we can show the contour. We can also show the vector. Vector is there. Vector we can show here. Similarly, path line we can also show here. And we can also this draw over the water and deflector plate is there. Water over deflector higher. See here. So this way you can show the streamline. Streamline means it presents how flow is going. That will be presented here. See, this is the stream path line. This way we can simulate, and you can post process. You can present in the your plot. Thank you for attending. For more requirement, you can see the this website. This website is also given CFD flow engineering for turbo machinery. Some courses are there here. CFD flow engineering. Just you can see the how to modeling of the turbo machinery. Visit this website. You can get lot of content how to model turbo machinery. So blade, vane, all content is given. Turbo machinery modeling in the ANSYS FLUENT. See, you can use the ANSYS platform. You can use you can watch this video. How to model using the turbo machinery. Any water wheel, water turbine is there. Some online classes are also available for the student. Courses his fee is just 3,500. We can attend this lecture. It will helpful for your future job and opportunity. Thank you.